For this problem, we will examine whether this series converges or diverges, summation n equals 1 to infinity, n to the third over 5 to the n. There are at least two different ways of doing this that are reasonable. One way of doing this is by the ratio test. So method number one, we use the ratio test. Yep, so let's see how this would go. Limit as n goes to infinity of n plus 1 cubed over 5 to the n plus 1 all over n cubed over 5 to the n. So the n plus first term divided by the nth term. Okay, so that we get limit as n goes to infinity of n plus 1 to the third over 5 to the n plus 1 times 5 to the n over n to the third. So limit as n goes to infinity of n plus 1 over n whole thing to the third times, okay, so here I have 5 to the n over 5 to the n plus 1, and so that cancels to be 1 over 5 to the first, because 5 to the n's cancel top and bottom. And as n goes to infinity, the fraction here goes to 1. So this goes to 1 to the third times a fifth, which is 1/5, which is less than 1. That's the important thing. And so because this limit is less than 1, we conclude that the series converges by the ratio test. Okay, so that is one way of going about the problem. A second way of going about the problem, which is about the same amount of work, is to use the root test. So let me change pages. Method number two. We use the root test. And so we get limit as n goes infinity of n to the third over 5 to the n, whole thing to the 1 over n. And so we have to evaluate this limit. Limit as n goes to infinity of n to the 3 over n over 5 to the n to the 1 over n. So that's the limit as n goes to infinity of n to the 1 over n to the third. And on the bottom here, I can just simply multiply these two exponents. N times 1 over n is 5 to the first. Okay, now I recognize this as one of the limits that I've got memorized. As n goes to infinity, n to the 1 over n goes to 1. So this goes to 1 to the third over 5. And by some coincidence, that's equal to 1/5. Importantly, that's less than 1. And so because this limit is less than 1, we conclude that the series converges by the root test. Okay, so that's all well and good. Let me conclude this video with one extra thought, and that is that another technique that you might want to try work, but doesn't work is going to be the limit comparison tests. So observation. So this is more of just an FYI note. The limit comparison test does not work. And the reason it doesn't work, at least for using the standard series we've got, if I took n cubed over 5 to the n, if I try to compare that to something that I know that converges, which is 5 to the n, I would get limit as n goes to infinity of n to the third, which is infinity. If this was some finite number, then I would be able to conclude that this converges. But because this is infinity, it may converge, it may diverge based on this test and this test alone. So this test is inconclusive. Yep. One other closing point, and I absolutely do not recommend this, is that this one also could be done by the integral test. If you've got absolutely nothing else to do with the rest of your life, you may want to try to do this with the integral test. It requires integration by parts 3 times. So I definitely don't recommend that, but it would work. If you integrate this by part with the integral test, you can actually integrate this and show that the integral of x the cubed over 5 to the x actually does converge, but it is painful and requires integration by parts 3 times.